Hello, this video is to go through a GCSE Chemistry Chromatography past paper question. So we have a setup here where a student has been doing paper chromatography. They've got some different food colourings and dyes that they've put on a line. So these are samples, and they're trying to identify X and see whether it's got any of A, B, C and D in it. And they go through the process as laid out here, but as ever for these questions, the student has made some mistakes. And so you are asked to identify the two mistakes you've made and explain what problems one of the mistakes would cause. So it's always worth checking the question. So first of all, let's look at it. Two mistakes. The very first thing we should spot, the water level is above where the actual dyes are, or above the start line. So above the dyes or start line. The second thing that they've done wrong, the start line itself is drawn in ink. So if you got both of these mistakes, you got 1 mark. And then you got the second mark by explaining the issue with either of them. I'm going to give you both just so you can see. So if the water level is above the start line, then what would happen is that the dyes would dissolve in the water. And you wouldn't get chromatography happening, you'd just get some slightly colourful water. The next issue is that the start line, if it was drawn in ink, that would run, or it would blur, or it would leach up the paper, it would move, it would run, and you wouldn't be able to measure where it was. So the start line would run if it was drawn in ink. You should draw it in pencil, and the water level should always be below the start line. Okay, another student set the apparatus up correctly, and here is a series of their results. They don't actually really talk about it here, but you can see the X, which is their mystery one, has got some of C in it. It's got some of, so if we look, it's got dye B, and it's got one here, which is a mystery, because it's not A, and so we don't know what it is. So 2 that we can identify, 1 that we don't know. Now, you're asked to calculate the RF value for dye A, so make sure you do it for the right chemical, and you have to give your answer to 2 significant figures. Go through your answers, highlight, and make sure you don't drop marks. RF is the distance to any dot from the start divided by the distance to the solvent front. Now, if you couldn't print this, you can pause, go back, and you can try measuring it on your screen because it's just a ratio. The answers I've got are different to the answers in the mark scheme because the way this is printed is not making it as large as what the actual original exam paper would be, but the value comes out the same because, as I said, it's a ratio. So whichever way you do it, you measure this distance here. I get that to be 2.6 centimeters, and I get this distance to be 7.8 centimeters. So having correctly identified the distances gets you 1 mark. Dividing them through gets you the second mark. So I got 0.33. I actually got 0.3333, but the third mark, always check how many marks things are worth, 2 significant figures, so I would put 0.33. The actual mark scheme suggests 2.8 divided by 8.2, which give a value of 0.34. And what you can see here, whenever there's one of these measuring ones, they always allow a range in the right area. So just remember, measure the distance to the dot from the start line, the distance to the solvent from the start line, and divide them. And pay attention to things like significant figures. Right, on to 7.3. Dye D has an RF value of 0.8, and you've got to calculate its distance. I've dramatically simplified this equation. RF, distance to dot, divided by distance to solvent. We're told it's 0.8. Oh, so this is what we have to find, the distance to the dot, and then we go back and take the distance that I had measured earlier, so I did 7.8. And now it's just rearranging an equation. I want to find the dot distance, so I'm going to times both sides of my equation by 7.8, and then if I quickly do that on a calculator, 0.8 times 7.8, 6.24 is what I get, and there isn't anything telling me about the number of significant figures or any decimal places, so I'm happy to leave it at 6.24. Right. Finally, we have to explain how different dyes are separated. The very first thing you have to get in, and there's three different phrases that would be acceptable for this. The water, which is otherwise known as the solvent, or the mobile phase, moves. That's the crucial part. The mobile phase moves through the paper or the stationary phase. So that's the first thing you always need to remember. Mobile phase moves through the stationary phase. Apologies, I'm writing slightly wider than this camera can cope with. The next thing is different dyes. Now, it was dyes we've used, but you could just put samples, because it will be dyes or inks or something. So different samples have different solubilities in, and you can either say the solvent, water, or the mobile phase. I'm just going to go with water for the simplest one. So when I've videoed the demo of this, I used a permanent marker, which is insoluble in water. It doesn't dissolve in water, so it wouldn't move anywhere. So your first part is how attracted to water they are, and the second part that you need to get in, and this is crucial, and different attractions for the paper. And again, you could replace water and paper with mobile phase and stationary phase. If something was really attracted to the stationary phase, it wouldn't move very far. If something was insoluble in water, it also wouldn't move very far. However, if it was not attracted to the paper at all, it would move quite a long way, and if it was really soluble in the water, it would move a long way. And the other ones would be somewhere in the middle. So if I just show you this here, B is really, really, really soluble and moves a long way. C is not very soluble, and so it doesn't move a long way. So this gets us 1, 2, 3 points, and I've hopefully just shown you how you'd get the fourth point, and that is by saying, so they move different distances, and that allows them to be separated. It allows you to prove that X is a mixture, and it lets you check that B is pure because it's only got one thing. Thank you.